All right, y'all seeing the screen? All right, cool. So what I'm going to talk about are those things, there's things that all of us have experience with. I'm going to talk all about pixels, at least what I know anyway. How about that? And since this is I'm going to use this as interactive time. There's so many helpers in here. If you guys want to jump in and offer your opinions or whatever, please feel free to do so. It's just more information that the people that use the room can call in about. So everybody's talked about all the different pixel designs. There's square, bullet, seed or pebble, strips, the new gumdrops, pucks, twinkly, and evos. Of these pixels, I basically only use bullets, but I have some gumdrops from Matos Design, the Matos Evos. Oh, they're over here, the Evos. Those work pretty good as well. So I'm going to be using those in some props where I needed lightweight. The gumdrop pixels are also lightweight. They run, I think it's about 1/4 of the amp draw, maybe even less than that, of a normal bullet pixel. So the goodness about the gumdrop, the Evos, and the seeds are the amp draw is much lower. So you can get by with more pixels and not use many power supplies. So again, these are all different pixels that can be used. I threw Twinkly in here because Twinkly was added to xLights, I want to say 3 years ago. So in xLights, there's a accommodation for Twinkly as well. Pucks can be any number of the pucks that are out there. But you see, normally they're multi-LEDs, but they all run WS2811. So since I said that, there's different protocols you all know about, or maybe you don't. The pixels that xLights support are WS2811, but literally they support all of these here, because if you go into the protocol information on every one of these pixels, you'll find that most of them do WS2811. And I've got a glossary here of pixel protocols. I'm not going to go over them all, but you can see how many different ones there are out there. So anyone that you would have information or want to know information on, you can go out to that site and look it up yourself. So again, WS2811 is what the bullet pixels are, and most of the others. Somebody asked, what does protocol mean? A protocol is a term used in communications, so how things work together. So it's a set of rules or guidelines that tell things how to communicate together. And that's used in different things in communication. In this case, because we're dealing with lights, it's how the lights work. So protocols are the rules, syntax, semantics, those type of things that basically tell them how they're going to be talking to each other. Protocols are used across hardware, software, and other things. So a big discussion is resistor regulated and what's the best. They both have their use cases. I copied this right off the Wired Watts page. So some things, notes of interest is the resistor pixels basically themselves create resistance and allow the pixels to go over, as compared to the regulated pixels regulate the voltage on each one of the pixels. Now the pixels actually only run at 3.5. So 3.5 is the lowest voltage you can get on a pixel. Sorry about that. And what happens across the resistor is, as it's going down the wires, the wire create resistance and it causes the voltage to drop. Once you get down by about 9.5 volts, you're going to notice your pixels start screwing up. They'll start flickering, they'll start blinking, whatever. But the resistors on the are doing their job on the and the wire is doing its job to bring the voltage down. So when the voltage drops below that amount, it's around 8, it stops working completely. 9.5 is when you're going to start seeing issues, but at 8 volts, you're going to see the pixels just start flaking totally. Again, it takes it down to 3.5 because it's reducing them all to 5 volts, and 3.5 is the lowest a 5-volt pixel can go. On the regulated pixels, they have regulators on them, or chips. And what the chips do is try and smooth the a flow of amperage across all of them, and it does a reduction down to 5 volts. So it does the same thing the resistors do, but the regulated pixels seem to have better or less voltage drop over distance. So if you have, again, this is Wired Watt's opinion. If you have a string that needs to go a long distance, they're recommending that you do it with regulated. So that's the difference between regulated and resistor. And all that information is out here on their page, so you can go out and look at it, right? Something though on this page, you can look at the pixels. The first one is 12-volt bulleted front and back with resistors. You can see the difference. It has one large chip on one side and then 3 small chips on the other. And if you notice this 12-volt DI and GND, that's the inbound side of a pixel. So when you're hooking a pixel up, that's where it's going to get the data line, the power, and the ground. The outbound side has no markings on it. So that's the difference. You can see them right there. If you look at a regulated pixel, it also has the 12-volt data in, ground, and the other side of it has no markings. But you can see the difference of the chips in the pixels. The regulated have basically only 2 chips, one on either side, one larger and one about half size. Ask about 5-volt. 5-volt pixels have only 1 chip on one side. They are also marked with 5-volt data in and ground. And notice some of the people that made them had arrows on them. You can see the wire on most of them. The wires are also marked, so you know which is going in, but not all of them manufacturers mark the wires showing the in and outbound side. So the only way to get to that is to look at the pixel and you can see it. And I'm sorry, I'm ill today, so. Any questions on that? Okay. As you all know, there's different connectors out there. There's a Raywu, X connector. Those are the 2 tops. X Connect is kind of Johnny new on the spot. Everybody's going to X Connect. JST is an older one. They're not really waterproof, but I use JST and Raywu. The difference basically between X Connect and Raywu is on X Connect, the nuts on the female, and on Raywu, the nuts on the male. So I don't know what that means, but I thought it was funny. So you can tell the Audi right there with the nut on it is the male side, and this is the female side and the nuts on it. So it makes them so you know you're not going to connect them. The other thing is the X Connect has a flat spot in it, pretty prominent flat spot on both the male and female sides. Some Raywus have them, some don't, but they again, the difference is the female doesn't have the nuts for Raywu, but on X Connect they do. Excuse me. So people ask about, how come I'm only getting 25 pixels lighting up? Well, you're only getting 25 pixels lighting up because you may not have configured your pixels right on your controller. So it could be a controller setting. So what I'm showing you here is like on port 2, it's got 388 pixels, with the first one having 194 and the second prop or model having 196. So if they say I'm only getting 25 lit up and it's configured for 368, that kind of tells you it's not a problem with the port configuration because you've got it configured correctly, but you would possibly have a problem with the string itself. So that's how you would, one way you could look at it. A lot of people use pixel testers. All of the vendors sell them. And you can use those to determine where your outage is. I know a year back or 2, Falcon came out with a pixel tester that does quite a few things. I have one in the cabinet. I've never used it. I bought it thinking it would be best thing since sliced bread, and it's sitting in the box that I got it in. So most of the time, 25 pixels light up. It's usually a controller setting. Other things people say is I go out to my controller and I push the button, test button, and everything lights up. Why doesn't it work from xLights that way? Well, When you push the test button on the controller, it literally floods every channel with pixel data. Because what you're doing in the test button on a controller is you're saying, I want to see if everything works. It doesn't know about your settings or anything else. It just sends and floods every channel that's available with pixel data. So if you're testing from your controller, hit the test button, you will see everything that works. But if you're testing from xLights and you're only getting 25, and you know you've got it configured to 388, then maybe you haven't uploaded that configuration, and you would upload the output to your controller, and then it would have the settings. I've already uploaded this one, so I'm not going to go through it again. But you would upload the outputs, and that's how you get your pixel counts, your channel numbers, and all that from xLights. So in Visualize, the visualizer, if you had available models, you would drag them to the ports, and that would assign the channels for those. As you can see right here, port 1, it tells the pixel number, it tells the channel numbers, it tells how much amp draw is coming from, it tells the brightness. So you would set all your models up on each port and then push the settings to the port with the upload output button. So to know that you got the upload output, you would go over to input output settings and channel outputs. And right now, I showed you port 1, and it had 75, 100, and 112. This is the last configuration I have, which is different than what I have in xLights because I have multiple. But you could tell if you're saying it's only doing 25, but yet the controller's set at 75, or total here of 200 and whatever it is, the number is. Again, that would point to something wrong with the string. So how you would troubleshoot that is plug another string of 100 in that port and see if you can get it to light up. You don't really need to try and change anything, but you can test it from here, or you can test it from xLights. Some controllers don't allow you to test from FPP. I'm not really sure which ones they are. I just noticed in the last couple years that we just couldn't test like we used to. So any questions on that, controller settings? Okay, cool. So sometimes by the way, these are all coming from calls we've had over the last 3 or 4 years I've been in this room. And thanks for those of you who helped me put these together. Somebody calls in and says, my pixel stays blue. Why is that happening? Well, usually it's a power rated issue or a controller or no data. So basically it stays blue because it's blanking the data. And again, that could be a problem with the pixel. It could be a problem with the controller, or it can be a problem with the power. If you've done everything in the first step to check your controller and make sure the configuration is right, then more than likely you've got a bad pixel. I've only seen blue pixel one time in 5 years, 4 years, but it's annoying. I do have one pixel that stays an off-white, and I just left it there because it's something to keep me annoyed. But no, this year I'm going to fix it, but it doesn't stop anything from going after that pixel. Normally when a pixel's going out, the ones after it start flaking out and doing weird things. So we'll talk about that more in a minute. I've got one pixel that's brighter than others. Well, that kind of tells you that pixel's on its way out. Most people, when they're replacing pixels, they usually replace the pixel before and the pixel that's flaking, because it's hard to tell if it's a chip on the previous pixel that's flaking or it's a chip on the pixel that's messing up. So my rule of thumb is I replace 2. Some people replace 3. Some people only replace the 1. Just do what you feel comfortable with. I've settled on replacing 2 every time I have a bad pixel. Only 300 of 500 pixels light up. If you check your controller settings and everything's working there, and now you only have 3 of 500, back to the setting here, we talked about your voltage drop. Once the voltage drops before a certain level, the pixels start not working. So normally it's between 300 and 350 per port on 12-volt resistor pixels that you'll start seeing them flake out. They'll just quit working. And that happens because your voltage drops. So the way around that is to do power balancing, or add power from that point on or from the end of the string. I'm not going to get heavy into power balancing or power injection. There's videos out there on that. and I'll point you to those in a minute. But normally, you don't have enough power. I personally power balance. I load my ports up with 800 because the controller will do it, and I power balance on the back side of the port. And I run most of mine at 30%. So at 40 frames a second with a Colt controller, you can get away with 800 pixels a port. Other controllers, results may vary. I think the Falcons are what, 720 or something like that. But after that point, they won't produce 40 frames a second. So you have to know what your controller does and what the capabilities are. Props go out after it rains. I had a great show, but it started raining and the back quit working. I know this because it happened to me multiple times. And I found out that the O-ring was missing. When I put it up on the house and I put it together, I wasn't paying attention to it and the little red O-ring fell out. So first thing you do is look at the connection and make sure your O-rings are good and that they're there. The other thing is some people like to use grease or dielectric grease on their connections. Don't use a lot of it, just use a little dab and put it on your male pins. And what that'll do is make sure everything functions and you shouldn't have a problem with power. So normally if they go out after a rain, it's because of O-ring or you get water intrusion somewhere, or you got a pixel that's going bad because the epoxy may be fractured and water's getting into the pixel. So that's kind of what that would happen. Everything tests from the test button. And I mentioned that in the first one. You have to go to your visualizer. You have to make sure that it's correctly put, number of pixels for each port, and then you have to push it. Once you do that and you go test again, you have to make sure, or you make sure then that it works correctly. But everything tests from the test button. It will always do that because, again, it floods pixel data to every pixel on that controller. Model is not lighting up. My first year, I kept having trouble with port 3 or port 4. I can't remember out in my front yard. And I knew I had done it right. I argued with someone here in this room. No, I got it right. No, I got it right. And Ryan finally convinced me, David, go out and look at it again. And I found out that I had wired it wrong. And I had port 3 on port 7 or something. So make sure your ports are correct. And you do that by labeling them when you put them together. I labeled them, but I labeled them wrong. So it's not something that is critical, but it helps you along the way for troubleshooting. All test well on the bench, but not lighting in the yard. Well, when you're testing on a bench, usually you're right next to the controller and you don't have all these extensions out in the yard like you do 25-foot extensions, 15, whatever length your extensions are from your controller to your models. So normally it would require a data booster or an F amp or a data boost. I can't remember if that's what it's called, but all the vendors have them. Data boosters help, as it says, but boost the data to the into the props. I use them quite extensively, again, because I do long runs and I have a lot of extensions in my show. One thing to note is if you have a Pixa booster from Wired Watts and you use a F amp from Falcon, you'll get mixed results. For some reason, they don't talk well together on the same line. So if you have multiples like I do, I just got to make sure I grab Pixa boosters or F amps if they're all on the same extension. My lights keep freezing. Well, excuse me. What causes them to freeze is they're losing data. My show runs and everything's flashing and then one bat stops and it just stays white. Well, what the heck happened? Well, it could be the first pixel has a bad, any of the things I've mentioned before. It has a bad chip and the data's not extending out. And so that props freezes and everything down the chain on that will freeze. So I have 5 bats on a chain and if the first one goes out, guess what? Everything after that goes out. So you have to make sure that to keep them from freezing that, your O-rings are good, your pixels are good, all the things I've mentioned before. So they'll freeze up if they lose data and they'll freeze up if they lose power. So it's hard to go between the two, but hopefully what I've discussed will help you get there. Lights at the end of the string stay on. That was an issue I was having. I had a vertical go out, and I have 4 verticals in a row, 200 pixels each, I believe. And the last one wasn't getting pixel data, but the very end of it was staying on. It's because I had power balancing, and it was getting power from the back end of the string on the fourth prop. And so it was powering them up multicolors, but it wasn't getting data, but it would get a data hit every occasionally. It would just change a little bit, but the power balancing was causing the end of the string to light up. So just make sure that if you see that, normally it's because it's a power balancing problem, or it's lost its data. It says losing data, lights in the string stay on. If a pixel's going out and the chip's going out and it can't pass the data, sometimes they'll stay on. Someone mentioned lights flickering white, and I was told that if you run excuse me, if you run the data next to the AC power, you get something called source power induction. Now, I'm not an electrician and I didn't stay at a Holiday Inn, but one of the guys in here who explained this to me said that the AC power going, or even the DC power going down, like if you're running them next to each other in the same conduit or whatever, it could cause the lights to flicker white. So you just need to make sure that if your power is next to it, you might want to separate those. So, excuse me. Lights work intermittently. I shake the prop and it works. Well, that happened to me, and I learned how to solder much better, but it was a bad connection. I used solder sleeves, and I overheated them, and it didn't work as well. So I had to replace the same solder sleeve 5 times, and I finally said, screw it. And I brought it down and I made a real solder joint. So a lot of times, if you have intermittent pixels or you shake it and it works, somewhere in that string, most likely where you have a junction or there's a connector, you've got a bad solder joint, and or you have water intrusion that's causing it to not make a good connection. Can't get string to light on port. So we've gotten that sometimes, and we try to convince people that they might have hooked it up backwards. And if we go back to this picture on Wired Watts, it kind of shows it to us what's happening. I can get it to open. If they don't hook it up right to this picture and the wire's not going in the right way, in other words, if 12 volts going in over here and data in over here and ground over here, it's trying to backfeed. So basically the polarity is wrong, and you can't do that. So you got to ask them to make sure they have it hooked up correctly, or other words, they just don't light up. There's a ton of videos out there, and I'm going to post this out on the xLights gems later, but there's different links on xLights that talk about how the things go wrong and what happens. The last one in this list is one Keith Wesley did. It's a few years old, but it's amazing how everything still applies. He talks about wiring and covers most of the things I just covered in this short tutorial, but you can go watch these videos, and these are all about pixels, wiring, connectors, all those things that are common issues in the pixel world. So are there any questions on anything I covered? If not, guys, have a great night. Thanks, John. Yeah, I wish mine was. All right.